Welcome to SDN Tech Forum. This is Linux Unix Masterclass and we are in part 4. Last class, as you have seen, we learned how to navigate and work with files. We looked into different environments, variables, and we ended up by analyzing processes with htop, top, and ps commands. In this class, we are going to revisit the processes and some of the other concept what we have learned in day 2 and day 3. Then we will build on top of that by adding more utility like find, grep, cut, sort, and then we will understand disk and partitions. We'll also look into some of the utility that can help you with automation, and for that we are going to look into awk, sed, for loops, and try to build a bash script. All right, so with that, let's get started. Here we are logged into our system and I'm going to show you what is our testbed look like. So this is Ubuntu 20.4 long-term release, Vocal Fosa, and that's been our platform so far. So let's look at one of the thing about permission. So let me see where we are and see if we have some file. All right, we have multiple directories and files here. As you can see, this part we have learned. This is about talk about permission and the users. As you can see, D is for directory, and then the first octet or the first column is read, write, and X is for execute. This column, the first column is for user, second column is for group, and third column is for others, right? So a user has to be part of group, and that's how you can segregate permissions between a user and a group, right? And we have learned that in previous video. I'm just going to quickly touch base on this. Let's pick up a file here, say new file. Here, as you can see, we have the permissions right now is read write for user and read write for the group, but only read for others. So let's go ahead and change the file permission. What you can do, you can use chmod and you can use an absolute value, say 644. That means user is 6, group is 4, other is 4. And then you can say new file. Yep, let's see what happened. Grep with new file. Now you can see the permission has changed, right? So you can change the permission like this, or you can use a more verbose or relative path by using chmod. And now I want, as you can see, the group has only read permission. If you want to change the permission for the group only, what we can see, chmod g, and I want to give this write permission. So g plus, that's the privilege we are going to add, w, and then say new file. Sorry about the typo here, chmod, and then again dual ls-l on that file, and as you can see, the permission has changed. So there are two ways you can change the permission. Why we are revisiting this? Because the default permission whenever you create a file, let's go and ahead and create a file, delete.txt, and see what is the permission assigned. As you can see, this is the permission 664, right? This is the default permission every time you create. And how this default permission is calculated? It's calculated using a concept called umask. And as you can see, my umask is 0003. You can ignore the MSP bit or the left hand extreme bit, you can ignore that. But as you can see, we actually do a combination and operation between the permission plus umask. So the default permission was 666, and then what happened, you subtract the umask from them, whatever is the system umask, and that's how the files get their default permission. In this case, this is 644. So what you can do, you can actually tweak umask so that your all the files created by the user have certain permission, I mean, you can modify the behavior by changing the umask. All right, that's why we are here. Now let's switch gear and how to change the permission. All you can do, you can write umask and then whatever value you want to put, right? So I'm happy with my default one. So let's not change that. Also, keep in mind, this ch mode is only changing permission for um, for the users, right? Who can access the file. There is another set of um, file permission that is with FACL. So you apply an ACL on the file itself. And for that, I'm going to show you. This is more granular control gives you on your file. So ch mode is impacting all the users and groups, but FACL, the file-based access control list, is of impacting one particular file. So just be aware that there are two different ways to control permission. All right, this is good. Let me do a clear here, and we are going to touch base on two more things from the past. Disk du is for disk uses, so ready verbose. What you can do, you can say du-h, and it will show you in like human readable form, megabyte, kilobyte, etc. And this is the disk uses, all the directories and etc. where I'm using some kind of storage. We can also do df-ht, and this is about your file system in human readable form. Like uh, what are the different file system you have? As you can see, we have temporary file system, we have our hard disk as dev sda2, and the type is external 4, and we will learn about different types when we go to partition. But this is how you can see what is your storage on your system and how much you are utilizing, right? So df-ht, human, and then the human readable, that means it give you the value in megabyte, gigabyte, etc. All right, let me go ahead and clear this. Now let's move to processes. So as you can see, we have learned about processes in past and how you can see processes. You can see processes like ps hyphen a, or simply ps, right? ps hyphen f, full processes, and you can do processes started by all the users. So ps hyphen a f is only processes started by me as a user, but if I want to see everything, you can see aef, that means all the users, started by all the users. Okay. Or what you can do a most extensive one, which is PSAUX, and it actually shows all the processes running on your system. All right. So this is how you can check processes. You can actually get the PIDs, etc. So this part is PID, and how they are attached. All those information is available in this terminal. Okay. All right. So why we are doing process? Because sometime it happen that some of the processes are stuck and you want to restart them and you want to force kill them. So for that, what you can do a p kill. So process kill, or you can then you provide the process number. So you can do process p kill hyphen PID, right? That's how you can kill the processes. I also like to show you the signals. What is the signals? So you can send signal to kill a process, and as you can see here, how many signals we have? We have by default we have 32 signals, and one of them which we use pretty frequently is sigkill9. So if you say pkill hyphen 9 or kill hyphen 9, then you can, and the PID, then you can kill a process. All right, but use this with caution. You don't want to kill the processes where your applications are running. Also, foreground, background, let's look at that real quick. So you can start a process, let's say start a dummy process called sleep, and now process is running. That means my terminal is sleeping. What I can do, I can do a control Z to stop the process. As you can see, the process is stopped and my terminal will become available. What I can do, I can also bring the stop process in the foreground by just clicking FG, and process is coming in the foreground. How you can cancel the process? You can simply see control C and process is cancelled. All right. So this is about foreground and background processes. Pretty straightforward. All right. In last video, you have seen some utilities, right? So let's go to there. And as you can see, we have some text, right? Some random text here. So let's start with grep. Grep, what is grep? Grep is a global re- regular expression and print. It's a common sequence of operation in early Unix text editor. It is also named as very useful command line utility. So basically what grep does, grep finds and print line in the file that matches a pattern. Right. So if you're using some kind of application like Notepad plus plus or BB Edit, we do pretty much all the time find application, replace application. And grep is essentially used behind the scene. Right. So let's try to do something with grep. You can, most of the time, we use grep with a piping command, like you are printing something, you're reading something, and then you want to grep. Like you have seen me doing grep ls-l, and then we do a grep for a file, or when we do process AUX, we can grep for a certain process, right? So it's very useful with pipe, but as a standalone also, you can use grep. So what I'm doing here, I say grep and find the with and this is case sensitive in our text file haiku.txt, right? As you can see, it matches the tau that is seen in my thesis. Thesis is not a complete word. This is matching a part of the word. So wherever it sees the pattern, it matches that, right? THE, that's the pattern it is matching. So you can also use some of the flags with it, and it's one of the key flag is restrict to the word. And for that, what I'm doing, I'm saying use the word. And when I say -I, that means make it case insensitive. So as you can see, now we are matching this pattern, we are matching this pattern, we are matching this pattern, but we are not matching thesis. Why? Because I have used W as a flag. That means just match the word. This pattern should be a word, standalone word, not the part of the word. And -N is very useful because it also gave us the number, line number, where we are matching this prompt. So grep, this is how you can use grep. Grep has another uh, very cool option, and let me show you with grep h. So the flags with grep are extensive. Let me just kill that. What you can do, you can also use -E option. And E option actually convert the grep from a simple pattern matching tool to a powerful tool, because you can use regular expressions. Yes. And as you can see, use grep and the flag -E, and then whatever here in the codes, they are not regular uh, characters. They are actually special characters with a significance. That means caret is start of the word, then dot is 1, and then O. So I'm saying that anything which is matching a start, one more character, and O, find that in the text. And now, as you can see, it's matching you, to, and software, because one or more character start with start of the line, and then we have an O followed by that, right? So this is how you can use um, regular expression with grep. All right. What we can do here, we can go to one directory up, and here we have some files. What you can do, you can also um, use to search. So grep is searching inside the file, or for a particular file. But if you want to search your system, what you can do, you can use a tool called find. And find, how it goes, it goes like find where, right? So you need to give a location. Let's see, I'm using my current directory, and then say hyphen name, and then you can use wildcard, not regular expression, but globbing using wildcard. And for that, I'm going to say dot txt. So as you can see, in my current directory, I have some uh, directories and some files, but I want to match anything which ended as .txt, right? Let's go ahead. Find path must pre, okay. So what you can do, all right, let me say, yep. So the hyphen was really not necessary. As you can see, these are the files what I have in my current directory, and it is actually looking inside the parent directory and also finding all those txt files, right? What you can do, you can mix grep and find together to do a look inside the directory, that you can do. All right. So this is grep, find, etc. now utility. Now let's talk about some of the behavior called standard in, standard out, and standard error. Right. Why I'm writing this? So that you can see. So standard in, what is standard in? Standard in is any input what we uh, give from, say, from our keyboard, or anything we echo. So if I do an echo, it is a test, it is a test, right? So standard, this is standard in because I am putting something from my keyboard, right? What is standard out? Standard out is anywhere you can actually display your standard in commands, right? So by default, the standard in a desktop environment is your monitor, and hence you can see when I do echo, it is a test, it goes into standard in pipe and spit out to standard out on my console, right? So standard in, standard out working together. Let's look at stand um, error also. So for that, what we can do, we can um, create some kind of file and try to generate an error, and that can show you that I'm going to standard error, right? So let me go ahead and create a file. But before we do that, it is a good idea to understand the variables, right? And by doing that, we can do two things together. So, all right, variables. So there are two type of variables. We have user-defined variables and we have system-defined variables. System-defined variables are fixed. Like if you click environment, you can see shell, pwd, log name, all those things in uppercase letter, they are variable, right? But they are set by system itself. What you can do, you can have your own user-defined variable also. Like say, for example, if I do w equal to sdn tech, and then echo this, as you can see, it echoes sdn tech. So this is a user-defined variable. Sometimes user-defined variables come handy when you write your own script, etc. So that's what you can do with variables. Now, while we are at variable, I want to show you uh, double quote and single quote behavior. So if I do an echo with double quote, which shell, and pardon the spelling mistake here, which shell I'm using, and I'm doing a $0, and it says shell, which shell I'm using bash shell, right? So this, since this is a system defined variable, and what if I do the same thing in single quote? Then let's flip it, and instead of double quote, I'm going to use a single quote and see what happens. So it's bit the literally whatever I wrote here, right? Which shell I'm using $0. So these are the quotes behavior, single quote, double quote, and that's what you should know, that whenever you're working with system defined variable or user defined variable, try to use double quote. All right, we were looking into um, standard in, standard out. So redirect, uh, redirect, and all those things, how you can do that. So what we can do, we can create a file, touch delete .txt, and then we can say cat delete .t. Let's do a nano delete .txt, and I'm going to say this is a test. Do a Control Shift O and Control Shift C. All right. Now if we do cat delete.txt, you can see the text is there, right? What you can do, you can also redirect the standard in to a file by using redirect. You can say open.txt, and it is creating a error which says no such file or directory, right? So we are trying to do in redirect to a open.txt, but there, since the file we have not created, it is getting us an error. So what you can do, you can redirect the standard output to or standard error to a file. So let's use the same command again. And this time what we are going to do, we are going to say 2 is for standard error and redirect to error.txt. It is spitting the error in standard out. At the same time, if we do cat error.txt, you can see, so it's hard to say whether we have error.txt or no. Find error.txt. And it is searching everything. Was not a good idea. All right. Find error.txt. Didn't find it. All right. So clear it out. And let's go to partitions. So what we can do, uh, we can do ls hyphen l here, and this is everything as a user. What we can do, we can go to cd dev, and if I do a ls hyphen l here, you can see these are all the devices, right? These are all the devices connected to my system, physical devices, virtual devices, any kind of devices, right? And if I do ls hyphen l and grep with sda, you can see these are the disk attached to my system, and I have sda as a disk, and it has 3 partitions. That's why you can see sda, sda1, and sda2, right? These are my disk associated to the system. What you can do, you can also look into the partition. So if I do sudo parted l list, and since we are doing sudo, we have to give the password, and you can see we have the partitions here, and there are 2 partitions. The first is small partition with file type FAT32, and this is, as you can see with the flag, this is a boot partition. So the file inside this partition will be used during the boot. And then we have our hard disk, which is 250 gigabyte and ext4. And ext4 is native Linux partition. Just like in Windows, you may have NTFS or FAT32, etc. In Apple, you will have HFS plus. In Windows, we have our native partition as ext4. Right? So this is how you can see what all is associated or to your system, what kind of partitions you have. And also, we will like to see a very cool utility called DD, that means copy and convert. So let me go back and say DD, this is unique. Okay, let me, so I wanted to search here. All right. So we will use a utility called DD to simulate some kind of read and write application or instance. So what I'm doing here, I'm saying DD if is input file, and I say dev 0. That means all zeros. OF is output file where you want to write. We want to create a new file called 0.txt with 250 zeros in it, right? So that's what we are doing. So actively, it is writing all zeros on this file, right? And while it is doing that, since it is finished very quickly, you can also do IOstat. IOstat is a utility that tell you how your input output um, consumption looking at that point of time. So as you can see, SDA is our main disk, and we have KB read and KB write, and this thing will increase as we do more DD if and um, off for 0.txt, right? So sometime if you want to check your IO state, that time you can actually look into DD or use the program called DD. Okay. All right. Now let's go back to the utility part. Before utility, let's look into some of the other utility, which is sort and unique, etc. Let me clear this. Right. Okay. So we are here, and now if you want to do sorting, so we have a CSV called animals.csv, and within that, if we want to apply cat animal.csv, then first 5 lines, last 3 lines, and then sort them, okay, in final.txt, which you cannot see here. So let me just remove that. And as you can see, we have first 5 line head, and from that we are picking the last 3 line. So piping command, first you did a cat animal.csv, the output was there. From that big output, we are saying pick five, top 5. And then we are saying out of those 5, pick last 3. And within last 3, we are saying sort with R, that means reverse order. Okay. So hence you can see sorted like this. So 19, 2, and 7. Okay. So this is how you can actually combine things. We can also do cut. What is a cut? Cut is used to remove or cut out certain sections of each line in the file, right? So if you want to do some cut here, first let me show you animal.csv right there. This is all our entries. And now if I do a cut -d and column F-2, that means column 2, okay? What you're getting? You're getting column 2 here. So this is column 1, and all the column 2 is selected and returned using cut-d. Interestingly, you will note that there are entries which are used multiple times. So deer is used 2 times, rabbit is used 2 times. So what if you want a unique list of entries? That means it's easy. You can use something very intuitive called unique, but you need to make sure that you are piping it right. And here you can see cut. We are using the same command, but this time along with sort, we are going to do unique. And as you do unique, you can see now there is duplicate entries are gone, and you have only bear, deer, and etc. No duplicate entries, right? So cut, short, unique, um, and head, tail, everything you can mix with piping. Right? It comes really handy when you are doing some kind of data manipulation. All right, let's move on to the another utility, very important and interesting one, is called awk. Awk is a pattern scanning and text processing language. So it is a language, it's not just a utility. What I'm going to show you is just the tip of the iceberg, but it's huge. So I advise you to go and do some further reading if you want to achieve the full potential of this programming language. All right. So what we are going to do with awk is it is something similar to cut, as you have seen. So in cut, you can uh, cut one particular column from a text file if it is some kind of comma delineated or any delineation file. So let's find some file where we have some output or text which is delineated. So this is one of the file output.txt, some router output, random output. Don't worry about that. What we are going to do, we are going to uh, run our awk operation on top of this file and try to uh, filter one particular column. So to do that, let me clear what we are going to say. We are going to say cat output.txt, pipe this. So as you see, uh, pipe is basically it will input the output from the previous command to, and it will make it input to the next command. And the next command is awk. To run awk in single quote, in curly braces, opening and close, what we want to do, we want to say print application and say column 1. You can use any column. So you can, I'm going to say column 1 and enter. As you can see, the output from the verbose output, the column 1 is filtered, pretty much like cut. But it is more, awk can do much more than this. So go ahead and read further. The second similar operation is SED. And what is SED? SED is a stream editor for filtering and transforming text. So basically, if you have used any text editor, you must have done find and replace. Sed is essentially a find and replace operation. So what you can do, let's look at the example. So I'm going to say echo or echo, it is my day, right? So it's echoed in standard output. And now let's perform a set operation on top of this. Same thing in single quote, within single quote, pay attention. The first is S, that means I want to do a substitution operation with S. Then use the delineation, whatever delineation you have. In my case, it's hashtag. And I'm going to say day, delineate it and replace it with night. All right. And enter. As you can say, it is my day converted to it is my night because I want to substitute day with night. All right. Let's take one more um, iteration and expand this text in I love my day and do the same thing. So as you can see, now we have output as it is my night like previously and I love my day. So what happened? The second portion was not replaced. Why is that? This is because sed by default is not a greedy operation. That means it only matches the first occurrence and then it is stopped, right? But that means it's not replace all basically. So what you can do to make it greedy or emulate uh, replace all, you can just add a flag, say G. G is for greedy, and you will see it is my night and I love my night. So all the day words were substituted with night. All right, so you have seen pretty much all the important utilities. Now I'll go back and touch base on standard input, standard output, and standard error one more time. So let's look at ls-l. These are the file or directory available at this directory, current directory. So let's try to find something which is not here. Why we are doing that? Because we want to generate an error, right? So now we know if a file is not found, it will generate an error on my standard out. So what we can do, we can redirect the error to a standard error file instead of showing it on my screen. And it is useful when you're running some kind of program or scripting. So I'm going to say cat path.txt and redirect it to um, say something fancy, no file.txt. At the same time, if there is an error, what I want to do, I want to redirect the error only with ampersand and redirect to error.txt. All right. So here you can see nothing showed on standard out. What happened? Let's look at cat error.txt, and cat error.txt has got catch all the error because it's not telling you that error.txt didn't find it. Under the content for error.txt is path.txt, no such file or directory. And if you want to see if we have error.txt created, you can see we have error.txt created here. All right. So this is how you can redirect error, and obviously ampersand redirect will overwrite. So if you want to append to the error, same, use double redirection. And if you will show you here, you can see 2 lines of error. So that's how you can redirect the error, standard error. Okay. What else you can do? Sometime you want to redirect the error and also see it on screen. So for that you can use T command, but obviously you have to make sure that you are using it at the right place. And here, so what it does, it display the error on console or on a standard out. At the same time, it also redirect the error to error.txt. And to verify that, we are going to do cat error.txt one more time, and you should see more lines of error. Here you can see from 2 we have 3 lines of error. So now you know how to redirect standard error, how to use T command and all those things. So this comes very handy when you're doing some kind of troubleshooting. All right, I think we are pretty good here for day 4. I have shown you all the utilities, etc. In next video, please join for the next video, because in next video it will be essentially Linux for network engineer. And if you see today, if I do conf, we don't have any networking utility installed. So in next video or final video, we will do a start our journey fresh with networking component, and I'm going to show you all the essential networking essentials a network engineer should know next video. So stay tuned. Thank you.